Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 3, Lesson 9 on equations of proportional relationships. So we've been working a lot with proportional relationships lately. We've been working with ratios and setting up proportions and solving them. We've been looking a ton at the graphs of proportional relationships. Today what we're going to start doing is actually putting the relationship between two proportional variables down into an equation that we can use both to just directly calculate things and also to solve some algebraic equations. So let's get right into it. One thing though I want to tell you is that I will be using my calculator a little bit today just to make the calculations faster and easier. Most of the calculations we do today you can certainly do longhand with long division, long multiplication, but they do tend to involve decimals, so you might want to have that calculator handy. All right, let's get right into it right away. Here we go, exercise number 1. A bake sale is selling brownies at a certain price per brownie. The total cost, C, of the brownies is proportional to the number of brownies bought, B. An advertisement states that 6 brownies cost $4.50. Letter A says Samantha buys 14 brownies. Let C be the cost. Set up and solve a proportion to find C. All right, well, you've been doing this quite a bit, so what I'd like you to do is pause the video now, set up a proportion, right, and figure out the total cost of buying 14 brownies if you know that the cost of buying 6 brownies is $4.50. Pause the video now and go ahead and do this. All right, let's do it. So pretty much all proportions you set up and solve as follows, right? I'm looking for the value of C, right? That's my cost per 14 brownies. I like bringing the units along with, equals another cost, $4.50 per 6 brownies. All right. And I like to have, my random red, I like to have those units there just so that I make sure that if brownies are in the denominator here, they're in the denominator here. If the cost is in the numerator here, the cost is in the numerator here. Now, once I've done that though, now pretty much I'll drop the units, I'll just do my cross multiplying and solve the equation. In other words, cross multiply here, 6 times C is just 6C. And here when I cross multiply, I'm going to get 14 times 450. Now that's where I like to have my calculator, right? Because although I can certainly do 450 times 14 longhand, that's not really the point of the lesson. So I get 6C is equal to 63. I can now divide both sides by 6. That's kind of awesome because I've already got my calculator out and I can just do divided by 3, that's going to take my last answer. Oh, not divided by 3. I actually need 63 divided by 6. Totally different. And I find 10.5. Now, because we're talking about a cost, right, then it's not great to leave it as 10.5. I'm going to leave it as 10.50 because that's a little bit more informative. $10.50 for 14 brownies. All right, so setting up a proportion. Oftentimes teachers will say C is to 14 as 450 is to 6. Let's now take a look at letter B, where we're going to use our answer from letter A. Here we go. What is the ratio of the brownie cost to the number of brownies? Set up as a fraction and evaluate using your calculator for both the 6 brownie case and the 14 brownie case. All right, let's talk about this. We want the ratio of the brownie cost to the number of brownies. So for 6 brownies, right, that's going to end up being a cost of $4.50 per 6 brownies. Now, if I want to create a unit rate from that, then of course what I do is what I've been doing all along, which is take the numerator, $4.50, divide it by the denominator, 6, and I end up getting 0.75 dollars per brownie, right, with the units. What I'd like you to do now is pause the video and do exactly the same thing for the 14 brownie case. All right, simple enough. For the 14 brownie case, we paid $10.50. Right? And we want to divide that by 14 brownies. And when we do that, right, $10.50 divided by 14, what we end up finding is exactly the same thing. Right? $0.75 or 75 cents per brownie. Okay, let's take a look now at letter C. The result in B should be the same for both, called the constant of proportionality. How do you interpret this unit rate? Now, side note, this is the whole point of two variables being proportional. If two variables are being proportional, then whenever we divide the value of one variable by the value of the other variable, the quotient, or the ratio, should always come out to be the same. In this case, 0.75. The question is, how do we interpret that? What does it tell us? And it should be painfully obvious from the units what it tells us, but pause the video now and write down how you interpret this unit rate. Well, it should be simple, right? For one brownie, we pay $0.75. Or you could say one brownie costs $0.75. For one brownie, we pay $0.75. All right. Unit rates are always about how much of one thing there is per a single unit of the other thing. Specifically, how much of the numerator there is per 1 unit of the denominator. One brownie costs 75 cents. Now, let's get into really what the topic for today is, which is how we relate the cost, right, to the number of brownies, letter D. If C is the total cost of brownies, of B brownies, then fill in the blank using what you've found. All right, simple enough, right? So because the cost and the number of brownies, right, are proportional, then C divided by B has to be equal to that 0.75. That's it. No matter what value of C and what value of B we use in this problem, if we take the cost and we divide it by the number of brownies, we're going to get 0.75. Now, maybe even more important is letter E. Solve this equation for the variable C. Why does this formula / equation for C make sense? Now, don't forget that whenever you're solving an equation for a variable, and specifically I want to solve it for this variable, we just want to kind of undo what's been done to the variable. Well, what is going on with C here? We're dividing it by B. In order to not have that division by B, what we're going to do is we're going to multiply both sides by B. Literally, the B's cancel out, and actually let me put this a little bit higher. We get C equals 0.75 times B. Now, that's simple enough, and that will always be the case whenever we have two variables that are proportional from one another. One way of thinking about that is, oh, if we divide one of them by the other, we get this constant. On the other hand, one of them will always be that constant times the other one. Now, this question also says, why does this formula for C make sense? Now, think about it for a minute. What does this see? What does this say? The cost, right, for buying this many brownies is going to be 0.75 times the number of brownies. That makes all the sense in the world, right? You know, so we just say the total cost, wow, I cannot get this thing to write. The total cost is equal to the price of one brownie, right? That's the 75 cents, times the number of brownies. Right? And that's exactly what you'd expect, right? If I told you that the cost of a single brownie was 75 cents, and then I said, hey, I'm buying 13 brownies, how much will it cost? Well, you would take the 13 brownies, you'd multiply it by the 75 cents to get your total cost. That's just how it works, right? If a loaf of bread costs $2 and I ask how many will 5 loaves of bread cost, it's going to be 5 times 2, it's going to be $10. Same thing here, we just have a decimal going on. In fact, let's use that now in letter F, where it asks how much would 2 dozen brownies cost? Use your answer from E. All right, so take a second, figure out how much 2 dozen brownies would cost. Well, one thing that we always have to be careful about is units, right? The last thing I would want to do is put in 2 into this formula. Because if I put 2 into that formula, that's really finding out how much 2 brownies will cost. But I want to know 2 dozen brownies. And what most of us should be pretty aware of is that 2 dozen brownies, right, since there are 12 in a dozen, will be 24 brownies. Therefore, if I want to use this formula to figure out the total cost, I'm going to do 0.75 times, not 12, let's try that again, times 24. And again, simple enough to do it on our without a calculator, but it takes time up that we don't really want to spend right now. So 0.75 times 24, enter, and we find $18. And that's really why we wanted an equation like that, right? We'd want an equation like that simply so we could then tell customers, oh, if you buy this many, this is how much it's going to cost you. This many, this is how much it's going to cost you. All right, let's keep going and do more work with proportional relationships. All right, so equations of proportional relationships. Let's talk about this a little bit, right? If x and y are proportionally related with a constant of proportionality, which is very oftentimes called k, why I don't know, right? Then when you take one of those variables and you divide them by the other one, you will get that constant every time, every time. Now, obviously, the order in which you do the division will give you a different constant of proportionality. Y divided by x will give you something different than x divided by y. At the end of the day, though, if you have y divided by x equals this constant, what that really means is that y is always equal to that constant times x. And that's what we saw in the last problem, right? C divided by B, the cost divided by the number of brownies, was equal to 0.75, which meant that the cost was equal to 0.75 times the number of brownies, right? When 2 variables are proportional or proportionally related, it just means one variable is equal to a constant multiple of the other variable, the multiplier being that k. So let's look at another exercise that kind of hammers this idea home. Problem number 2. Water is flowing into a swimming pool at a constant rate. The volume of water that has entered the pool is proportional to the amount of time it's been filling. After 5 minutes, 41 gallons have come into the pool. Letter A asks us, what is the constant of proportionality in gallons per minute? Show the fraction and then the decimal answer with units. All right, this should really be quite easy. So what I'd like you to do is pause the video now, set up a ratio, use your calculator to help you with the division, and then express the unit rate, and it's going to have some decimals in it. Pause the video now. All right, well, we want gallons per minute. Gallons per minute, that means we want the gallons in the numerator and the minutes in the denominator. That can be a little tricky given where they've showed up kind of in the problem. But we just simply want 41 gallons divided by 5 minutes. Notice how often we end up having time in the denominator. Minutes, hours, seconds, whatever. There's our ratio. Now, we can sort of make the evaluation quite easy using the calculator. We'll just do 41 divided by 8. Oh, no, not 41 divided by 8. Let's try 41 divided by 5. I don't know where the 8 came from. That's weird. All right, 41 divided by 5, and we get 8.2. And specifically, right, we get 8.2 gallons per minute. All right, and there's our unit rate. And it's so easy to interpret that. Every minute that goes by, 8.2 gallons go into the pool. All right, let's now see what we can do with that 8.2 in letter B. Let G be the gallons of water that have entered the pool. So it's the total amount of water that's entered the pool in gallons. And M be the number of minutes that have passed. Using your answer from A, set up a proportion and then solve it for G. All right, this is so cool. We know that G, the number of gallons, is proportional to M, the number of minutes. By the way, the reason that we know that's proportional is because they told us that we have, whoops, there it is, a constant rate. And in fact, that constant rate is 8.2 gallons per minute. There's your rate. All right. If we now want to set up an equation that relates G to M in general, it's very simple. We just kind of do the same ratio that we did before, except with variables instead of numbers, right? The number of gallons divided by the number of minutes will always be a constant. What will be that constant? 8.2 gallons per minute. So we can write G divided by M is equal to 8.2. Now we can multiply by M on both sides, and we just find that the number of gallons is always 8.2 times the number of minutes. Every proportional relationship will always look like some variable equals a number times some other variable. Always, always, always. All right, now let's see what we can actually do with that equation. Once we have an equation, we can tend to do quite a bit with it. So letter C. Use your answer from B to find out how many gallons of water would enter the pool in 1 hour. Awesome. Well, you've got your equation that tells you the number of gallons will be equal to 8.2 times the number of minutes. You've got a calculator to help you out as well. You try to answer letter C, how many gallons will enter the pool in just 1 hour? Well, again, all we really have to be careful with here is not to put 1 in for M. That would be the number of gallons that would enter after 1 minute. After 1 hour, the number of minutes, as we should be painfully aware of at this point, is 60, right? There are 60 minutes in 1 hour. Okay? So if I want to use my equation now, I'll say the number of gallons will be 8.2 times the number of minutes. So the number of gallons will now be, using my calculator, clear that last calculation out, 8.2 times the number of minutes, 60, gives me 492. That might seem like a lot, but an average pool can hold a lot of water. 492 gallons. All right, let's take a look at letter D. The pool needs 1,230 gallons. Set up an equation and solve it for the number of minutes M that it will take. Little grammar mistake. It should say set up an equation, not and equation. That doesn't make any sense. All right, so let's talk about how we can set up an equation. The cool thing about a proportional relationship, right, is that sometimes you're sort of given the value of this variable, and then you just have to do a multiplication to find this variable. On the other hand, in this situation, what's happened is they've told us the number of gallons, right? 1,230, and we're trying to figure out the number of minutes it's going to take to actually fill that up. So in this case, what we're looking at is we're looking at solving this equation. 1,230 equals 8.2 times M. Now, this is a very, very simple one-step equation, right? In order to solve this equation, all we need to do is divide both sides by 8.2, right? Now, back in 6th grade math, that would have been a huge pain because we would have had to have done that long division using the decimal. On the other hand, here, come back to me, calculator. Here, all we have to do is type in 1,000. Let's try that again. 1,230 divided by 8.2. and we find it's going to take 150 minutes. All right. And again, when we have an equation that is this simple, we can really be asked to do one of two things with it. Either we're given the value of this variable, and then it's a simple multiplication to get the value of this one, or we're given the value of this variable, and then it's just a simple division to figure out this one, which makes a lot of sense. Let's take a look at the last part of this problem. Maybe move the calculator a little bit out of the way, bring this up some. A second tap of water is turned on to help fill up the pool. If it adds 58 gallons in 8 minutes, which tap has a higher rate? All right, pause the video now and see if you can figure this out. Well, we know the first tap that we turned on is filling up the pool at 8.2 gallons per minute. Every minute that goes by, 8.2 gallons goes in. To figure out the rate that this tap is filling up the pool, we also have to set up a ratio and then turn it into a unit rate. So we know that we have 58 gallons per 8 minutes. To create a unit rate on that, we're going to do the same thing that we've been doing all along, which is we are going to simply take our numerator, divide it by our denominator, which is all a fraction really is, and we find 7.25 gallons per minute. And so we can now say that the first tap had a higher rate, right? Because it was 8.2, and this one is only 7.25. Okay, and that's it. Let's summarize the lesson. There it is. Couldn't figure out where my direction marker was. All right, so in today's lesson, right, we reviewed a lot of different things that we've already seen, including how to turn ratios into unit rates. But one of the things that we extended in this lesson was to really take the two variables, whatever they were, the cost, the number of brownies, right, the number of gallons of gasoline versus the cost, things like that. We take those things and we change them then into equations that specifically relate the two variables, right? And those equations are very simple. They're one variable equals a constant times the other variable. All proportional relationships look like that. A variable equals a number times another variable, that number being the constant of proportionality. Its units can help you know which way that sort of equation should work. Which variable should be on the left, which variable should be on the right. We'll work with these just a little bit more in the last lesson of Unit 3. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.